Today, I wanted to just recap what we talked about last time with regards to circumference and area before I jump into our new topic. So let me remind you, circumference is equal to 2 pi radius or pi times diameter. Either one does not matter. Okay, I look at my picture and I see that they have given us a radius of 6. It goes from the middle to the edge. So I'm going to use this second formula, 2 pi, and I'll put 6 in the radius spot. So that is 12 pi as an exact answer. As a rounded answer, that'd be 12 times 3.14. And let me type that in. That would be 37.68. That is your 2 decimal answer. So if I say exact, that means in terms of pi. If I say rounded to 2 decimals, I want rounded. So for this one, I'll go ahead and do 37.68. For area, we have area equals pi times the radius squared. Again, our radius is 6, so pi times 6 squared. So I have 36 pi as an exact answer. And then if I want to round that, I'll have 36 times 3.14. And that is going to give me 113.04 to 2 decimals. Okay, so just pay attention. If I don't give you directions, assume that I want the decimal value. Here we have a pizza. Okay, yummy looking pepperoni pizza. And we're doing circumference and area again. I'm going to use pi diameter because I can see that the diameter is 14. Okay, I will make note that means the radius is 7. So I have pi times 14. So 14 pi as an exact, or 43.96 inches as a rounded answer. So that would be the amount of crust around the pizza. And for area, we have pi times radius squared. Remember, our radius is 7. It's half of our diameter. So pi times 7 squared, 49 pi. If I do 49 times 3.14, I get 153.86 inches squared. 153.86 inches squared would be our area for this piece of pizza, or for this entire pizza, I should say. Today, we're going to talk a little bit about arc length and sector area. So just to remind you, let me get a circle here. Okay, so we're doing circles. And we learned last class about central angles, right? And a central angle has a degree measure between 0 and 360. So maybe this one is, I don't know, 94 degrees. And we talked about an arc, okay, or a piece of crust, as having the same measure. So when I talk about arc length, that's going to be different from arc measure. Okay, so the degree is the measure. Length is how much of the overall circumference is taken up. So it's actually something you could attach units to, like inches or feet or whatever. Okay. And I know that when I do my measure, it's out of 360 degrees. Whatever that ratio is, it should be the same for the length over the whole circumference. Okay. So we're basically converting from measuring in degrees to measuring in whatever the circumference is measured in. Okay. So the arc portion out of the whole circumference is the same as the angle out of the whole 360. So this is the formula I just showed you. Again, I usually use like a kind of cursive L for arc length. And you kind of just want to think about it. Degrees compares to degrees. This might be like inches compares to inches or whatever your unit happens to be. So I look at my picture and I'm like, okay, here's 62. That's a degree measure. So I'm going to have 62 over 360 equals, I don't know my arc length. So L over 2 pi, and then my radius I can see is 25. To solve this, I'm going to cross multiply. Okay, so all of this will multiply together. And I'm going to keep the pi sign off to the side for right now. So I'm going to do 62 times 2 times 25. Gives me 3,100 pi equals 360 L when I cross and multiply those. Okay. If I want L by itself, I just need to divide by 360. Notice I'm still just keeping pi off to the side. So I divide by 360 and I get like 8.611111. So I'll stop it there. Pi. You could switch that back to a fraction. Okay, that'd be 155 over 18 pi. So this is a good answer. This is a good answer. But if I want it rounded, what I would do is type in 3,100 times 3.14 divided by 360. I would type it in exactly like that. And when you do that, you get 27.03888888, so 0.04. Okay, I would be pretty lenient with my rounding, so that would be your answer. That is the arc length. So the arc was 62 degrees out of the full 360. It's 27.04 out of the full 50 pi or whatever. Okay, so here we just have another practice problem. 135 is our degree, compares to degrees. Degrees equals length over 2 pi 8. Cross multiply again. Keep the pi off to the side until the end. So we have 135 times 2 times 8 is 2160 pi equals 360 L. I always try my dividing to see if it's nice. In this case, when I divide by 360, I get 6 pi equals L. So that would be your exact answer. If you do 6 times 3.14, that would give you 18.84 equals L. That would be your rounded answer. Your homework is going to be a math space, and all of them, I'm fairly certain, will ask you for the rounded answer. I added in one more arc length formula because I wanted you to see that we can do arc length for a humongous portion of the circle as well. So I see my 315. I know that's my degree. So degrees compares to degrees. So 315 degrees out of the full 360. We're looking for the length of this arc. So how much this actually measures. Okay, so the length over 2 pi 8. Same old thing. 315 times 2 times 8 equals 5040 pi. So 5040 pi equals 360 L. Divide by 360. You get 14 pi equals L. If you do 14 times 3.14, you'll get an arc length of about 43.96. That's all there is for arc length. It's really not a lot. Sector area is not going to be much different. Okay, so we have our circle and we have our central angle. I'll stick with that same number I used before, that 94. Okay. And what we're going to be doing here is we are going to compare that measure, so that 94 over 360. Okay, this is our radius. I don't know what it is. Equals the sector area compared to the whole area, which is pi r squared. Okay, so that formula would tell me how much space this sector takes up. Okay, so 94 out of the 94 out of the full 360 degrees should compare to that amount of area out of the entire area. Okay, so essentially the same formula, just with sector area compared to area now. That is the only difference. Okay, so looking at this one, again, degrees compares to degrees. So 80 compares with 360. It tells us to do area of the shaded sector. So you do have to read the directions, but that's about it. Pi 4 squared. I would highly recommend changing this. So 4 squared is 16. So when you cross multiply, you don't mess up the squaring part. Okay, and I'm going to keep the pi off to the side again. So 80 times 16 is 1280 pi equals 360a. Divide by 360. And you get 3.55 on and on and on and on. Okay. Pi. So that's about 3.56 pi if we stick with my 2 decimal places. I'm going to go ahead and multiply the pi in since I'm already in decimals anyways. If I do that, I get roughly 11.1784. Again, there is room for error with your rounding. And that would be in feet squared because area is always measured in units squared. Here we have 135 out of 360 degrees to degrees equals the sector area compared to pi 12 squared. 12 squared is 144. Okay, I'm going to cross multiply. 135 times 144 is 19,440 pi equals 360 times the sector area. When I divide, that gives me 54 pi equals the sector area multiplied by 3.14. 169.56 would be my answer. Last but not least, they want to know the area of the rest of this pizza. So 300 over 360. Sorry, that was a little bit hard to read. Okay, so we have the 360 with the 300 equals A over pi times 10 squared, which we know is 100. Okay, 300 times 100. Oh my goodness, I'm typing too many numbers. So we have 30,000 pi equals 360A. When we divide, we get 83.33 pi equals A. Multiply by 3.14. And you should get about 261.66 centimeters squared. Don't worry about including the units. I know they're hard to type. Okay. Okay, so to summarize, before I give you kind of like a problem to do on your own, if you're doing arc length, you're always doing your measure out of 360. So remember, degrees compares to degrees. And that should equal your length over 2 pi r. I just use 2 pi r for my circumference formula because it's easier than mixing up formulas. Okay, for sector area, still m over 360. So degrees to degrees equals the sector area over pi r squared because that's the whole area. So part out of 360 equals part out of whole circumference. Part out of 360 equals part out of the whole area. On the next and last slide, there's going to be a picture. And I'm going to ask you to find both the arc length and sector area for Pac-Man. Okay. And then that'll be it for notes. And you have a 5-question math space to complete. And that's it for the day. So for this problem, Pac-Man has a mouth with a radius of 7 inches. Okay, so 7 inches here. And a body that has a central angle of 265. So right here, this angle is 265. I would like you to find both the arc length and sector area for Pac-Man. So the sector area would be the yellow portion. And then I'm looking for the arc length of his outer edge. Okay, don't include his mouth. And I would like you to round to 2 decimal places. So I do want you to multiply through by 3.14 at the end.